Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem Pintu and Fruits with the difficulty level of cakewalk. Let's get started with reading the problem statement. Here it's written that Pintu sells m different types of fruits numbered through 1 to m and he sells it in n baskets numbered from 1 to n. For each valid I, the ith basket contains pi price and the fruits of type, it contains fruits of type fi. So for each valid I, the ith basket costs pi and contains fruits of type fi. Now chef does not have too much money, he cannot afford to buy everything. He wants to choose one type of fruit and purchase all the basket containing that particular fruit. Help chef choose such type of fruit to buy such that he buys at least one basket and the total cost is minimum possible. So let's look at a few sample cases to understand this. Here there are four types of fruits. 1, 2, 3, 4. This means that 1 to 4 are the types of fruits. Let me write it here. Types of fruits. Now there are n baskets, which means that there are 6 baskets. 6 baskets. Now here we know that this is of type this basket is of fruit of type 1. This basket is fruit of type 2. This basket is fruit of type 3. Fruit of type 3, fruit of type 2, fruit of type 2. If we want to sum up all the prices of fruits of type 1, what will it be? You remember that this is the type of fruit and this is the price of that particular type of fruit. Now I want to sum up all the fruits of type 1. The price of all fruits of type 1, we know that it is only 7 because we have only this particular type 1 fruit. Now I want all the fruits of type 2. If I want all the cost of prices of all fruits of type 2, it will be 3 price 3 plus price 1 plus price 1. 3 plus 1 plus 1. This is basically the type of fruit. This is basically the total price. The total price. 3 plus 1 plus 1 is 5. If I want all the fruits of type 3 in all the baskets, it is nothing but what do I have here? I have price 9 and price 1. So 9 plus 1 will be 10. Now we know we have 4 types of fruits, but corresponding to 4 we don't have any baskets here. So there is 0. Price is 0 for type 4. But in this particular case, we need to note this answer here will be 5. The minimum of this is 5 and not 0. And this is very important to note this, that the answer here cannot be 0, because let's modify this a bit. Let's say there are 7 baskets. Okay, if there are 7 baskets, we'll keep the starting same, we'll keep this type of fruit same, we'll keep the price also same. But what we will do now is we will add a new type of fruit. We will add fruit of type 4 and then we will say price is 0 for type fruit 4, type 4. Now for this particular input, what will be the output? Will it be 5 or will it be 0? Please understand, in this particular case, this type 4 is not even present in our input. So it cannot contribute part of our answer. What we are going to do is very simple. For each type of fruit, basically from 1 to m, we will see the total price. Basically what we did here, for fruit of type 1, we summed up the prices in all the different baskets corresponding to type 1. Then we summed up all the prices corresponding to type 2. Then we summed up all the prices corresponding to type 3. Then we summed up so on, and then we took the minimum. Then we take the minimum of the total price. That's how we solve this problem. But here I'm telling that the output cannot be 0, because normally if you look at it, you see 7, 5, 10 and you see 0. Then you will be like, well, 0 is the minimum here and 0 should be the output. No, 0 cannot be the output for this case that is given to us, because we do not have any fruits of type 4 here. So in this particular case, since there is no fruit of type 4, then it cannot be there. If 4 is part of our input, then here in this particular case 0 can be our answer. If 4 is part of, if there are 7 baskets and 4 type of fruit, and here 4 is part of our input, because 4 is part of our input, then while taking the minimum we have to consider this 4 and this 0 here. While if 4 is not even part of our input here, only we have baskets of type 1, baskets of type 2, baskets of type 3, we do not include 4. So hope this part is clear here. So what we're just going to do is run a loop, and then we will run a loop from 1 to m, and then particularly corresponding to this type of fruit, type 1, what we're going to do, we are going to sum up the prices in all the different baskets. Then we go to type 2, corresponding to fruits of type 2, we sum up the prices in all the baskets. Then last we go to type m, corresponding to type M, we sum up all the baskets. So hope this part is clear. Now let's look at the code for the approach that we have just discussed. Here, after inputting M and N, we can ignore this map here. After inputting M and N, we input the types of fruits first. We know that type of fruit is Fi basically, for I from 0 to N minus 1 or 1 to N, whatever based indexing you want to take. First we input the type of fruit, then we input the price. Because if I just scroll up and show you the sample input, here we first take N, which is the number of baskets, then we take M, which is the types of fruits from 1 to 4 here in this case, then we input the types of fruits, then we input price corresponding to the type of fruit, then in the basket. So first we input N, then we input M. So N is nothing but number of baskets and M is nothing but basically the types of fruits, and this means that the types of fruits can be from 1 to M. 1 to M. Then we go to then we input the arrays, types of fruits and prices. Then we have a variable minimum that is initialized to a very high value at the starting. Then corresponding to every type of fruit from 1 to M, we will find out the sum of the prices corresponding to all baskets of that particular type of fruit. So J equal to 1 here, all the baskets that have fruits of type 1, we will sum up all of their corresponding prices to get the total price. If chef selects fruits of type 1, we know that he's going to buy all the baskets of type 1. So if he selects a particular type of fruit, we need to sum the price over all baskets that contain that particular type of fruit. So that's what we do here. We have total price equal to 0 corresponding to the selected J, and then we have an inner loop here that runs through all the baskets and checks, is this basket containing fruit of type J? Here, if yes, we have found equal to true, and then we do total price plus equal to price. So basically what it does is, suppose we want to find out the sum of prices over all the baskets containing fruits of type 1, because J initially starts from 1. Let's say this one. Over all fruits of type 1, we want the total price. So what we do is, we run through this second price array and we check, is this particular price corresponding to this particular type of fruit 1? Yes, 7 is corresponding. So to my sum, I will add 7. Then I find no other fruit of type 1. So that's all. But in case I want to find out the total price corresponding to the fruit of type 2, what I do is, I again run through this array, and for each element I check if my type equal to 2. Is 7's type equal to 2? No. Is 3's type equal to 2? Yes. So in my sum, I'll add 3. Then the 9's type is 3, ignore. 1's type is 3, ignore. 1, now corresponding to this price 1, actually 2 is here. So this is also of type 2. So I already had 3. I need to add the price 1. 3 plus 1, 4. Then again I go here. Corresponding to this one price also, I have my type as 2. So I already had my sum as 4. My sum becomes 5. So basically if I ask you, corresponding to fruits of type 2, what is the sum over all baskets containing fruits of type 2? You'll just look at this once and you'll say 3 plus 1 plus 1. Because these 3 are the only baskets, this 2 and this 1 are the only baskets of type 2. So corresponding to them, we need to sum up their price. 3 plus 1 plus 1. That's what we do exactly here. So total price contains that. Then we have the minimum condition, which is a normal finding the minimum. But one very important case is, I want to pause the video and find out why we need this condition and why the solution will not work without this found condition in this implementation. You can also, this is an M into N approach, and because the constraints are very low for this particular problem, we just have 1000 test cases and M and N are 50, and then price can be from 0 to 50. So very small constraints. This will pass. You can even try another approach where you use a count array, use a map, and you can reduce the complexity from M into N to just linear, M plus N also, but you can try that later. But here for this particular case, I want you to tell me why, if I remove this condition of the Boolean variable found, why the solution will not work. Now let's look at this particular case. I'll change the input as 6, 4 here. There are 6 baskets and ignore this for now. So in order to find out the minimum minimum price that chef has to spend in order to buy the fruits, what we do, corresponding to fruit of type 1, we say that the total price is 7. If chef chooses type 2, fruits of type 2, we tell him that the total price is 5. Corresponding to fruits of type 3, we tell him total price is 9 plus 1, that is 10. So we take the minimum and we tell that for this particular case, the minimum answer is 7. The minimum answer is 5, sorry. Minimum answer is 5. Because 7, 5 and 10, minimum is 5. And we have this. But you need to remember that in our J loop, we run it from 1 to M, right? And in this particular case, M was 4 here. So our J loop will run from, it'll run for 1, it'll take 7 as a correct thing, it'll run for 2, it's fine, it'll run for 3, it's fine. But when it's equal to 4, our inner loop will try to search our price array and it will check whether that particular index basket has fruits of type J when J equal to M. In this particular case, there are no such fruits. So in our case, our total price will be 0 itself. And then for this, if we don't have the variable found, our minimum will not be 5 in this case. It will be 0. But we do not want 0 in this particular case. When do we want 0? We know that the prices of certain baskets can be 0 also. So for example, if I had another case here, in this particular case, because we have fruits of type 4, whose price is 0, that can contribute to our answer. This means that if chef chooses fruits of type 4, which is available in our input for this particular corresponding to this basket, if chef chooses fruits of type 4, the total price he has to spend is 0, which is minimum in this case. But the case what we had was not this. The case what we had was this basically. In this particular case, there is no way that chef can choose fruits of type 4 if you don't even have it in your input. So here, instead, if we have the normal finding the minimum without this found condition here, our output will be 0, like I just discussed. We have 7, 5, 10 and 0 and our minimum will get 0. So to combat this condition, we will only calculate the minimum in those conditions where our fruit of type J is found in our input. So I'll repeat this again. We will compute our minimum condition only in those cases where our fruit of type J is found in our input. So for this particular case, even though corresponding to 4, we will get total price as 0. The minimum condition will be computed for only 1, 2 and 3 because we have the condition that we will compute the minimum only for those fruits of type we find in our input. So hope this part is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.